Hey everyone, have you ever grabbed a mug of hot chocolate and wondered, wow, why does this feel so warm? Or what about an ice cube? Why is it so cold? Well, today we're going to become heat experts. We're diving into the amazing science of heat. Let's get started.
Okay, so let's kick things off with a little puzzle for you. What's the real difference between something that's hot and something that's cold? You're probably thinking, I just touch it and I know. But what if I told you that your own hands can sometimes play tricks on you?
I know, it sounds easy, but stick with me because we're about to discover how our amazing sense of touch can get a little, well, confused. It's pretty wild.
All right, so first up in our investigation, how do we actually feel temperature? We use our hands for everything, right? But can we always trust what they're telling us? Let's find out.
Okay, this part is pretty simple. You touch a warm mug of tea and, yep, it feels hot. You touch an ice cube and it feels cold. Our hands tell us that right away. But that feeling, it isn't always telling us the whole story.
Let's do a little experiment right now, just in our minds. Picture 3 bowls of water. Now imagine putting one of your hands into a bowl of really chilly cold water. Brr! Okay, now put your other hand into a bowl of nice warm water. Ah, that feels good. Now, you ready? Imagine taking both hands out at the same time and plunging them into that third bowl, the one with just normal room temperature water. What do you think's gonna happen?
And here's the surprise. The hand that was in the cold water will suddenly feel warm. And the hand that was in the hot water, it's gonna feel cold. But wait, they're in the exact same water. How cool is that? It just proves our sense of touch can totally be tricked. So if our hands aren't reliable, we need a better tool for the job.
So, if our hands can get confused, what can we use instead? It's time to bring in the hero of our story, our super science tool, the thermometer.
See, a thermometer doesn't have feeling, so it can't be tricked. It measures something called temperature, which is the actual measurement of how hot or cold something is. It gives us a real number, so there's no guessing involved.
So how does this cool little tool work? Well, inside that thin glass tube, there's a special liquid. When things get warmer, that liquid actually expands. It stretches out and rises up the tube. And when things get colder, the liquid contracts or scrunches up and falls back down. So simple, but so clever.
But hold on, not all thermometers are created equal. Just like you have different shoes for running and for the rain, we have different thermometers for different jobs. Let's have a little thermometer showdown.
In one corner, we have the clinical thermometer. This is probably the one you've seen a doctor use. And in the other corner, we have the laboratory thermometer, which is what we use for all sorts of cool science experiments. They might look alike, but they're designed for very different things.
This chart shows us the biggest differences. A lab thermometer has a huge range. It can measure things that are freezing cold all the way up to things that are boiling hot. But a clinical one, it has a much smaller range because it only needs to measure our body temperature. And it has a secret weapon, a special little thing called a kink.
So what in the world is a kink? Just think of it like a tiny little pinch or a bend in the glass tube. It acts like a stop sign. Its whole job is to stop that liquid from falling back down too quickly. This is super important because it gives you a chance to take the thermometer out and actually read your temperature. Lab thermometers don't have that, so the liquid moves right away.
Okay, we figured out how to measure heat. But how does heat actually get from one place to another? If you can understand this, you can understand how to stay warm in the winter and cool in the summer.
Let's imagine we can shrink down and follow one tiny little particle of heat. Picture it sitting on a hot stove, just buzzing and wiggling around with tons of energy. It's ready for an adventure.
It's got so much energy it just can't sit still. It's got to go somewhere. So, with a big burst of energy, it jumps. It leaps off of that hot stove
And flies right into the cooler air that's all around it. And that, my friends, is the most important rule of heat. It always moves from something hot to something colder. Always. It just loves to share its energy. It's like how the heat from a bonfire warms you up when you're standing nearby.
And guess what? Your body is a total genius at using this rule. When it's a super hot day, you start to sweat. As that sweat evaporates, or turns into a gas, it needs to grab some energy to do it. And where does it get that energy? From the heat on your skin. So as the sweat disappears, it takes heat with it, and that's what cools you down.
Now that we're basically heat experts, we can use science to make smart choices every day. Like, what should we wear?
Think about it. In the summer, we wear light-colored clothes, like a white t-shirt.
That's because light colors are great at reflecting the sun's heat away from us. But in the winter, we wear darker colors, which are better at absorbing the sun's heat. And we wear wool, which is amazing at trapping our own body heat to keep us nice and toasty.
So what's wool's big secret? Well, all those fuzzy little fibers in a wool sweater are pros at trapping tiny pockets of air. And air is actually a really bad traveler of heat. So that layer of trapped air acts like your own personal, cozy, invisible blanket, keeping your body heat in and the cold out. Okay, we've learned so much, but before we wrap up, we have to talk about one last important thing. Science is awesome and fun, but we always have to be safe, especially when we're using science tools. So if you ever get to use a glass thermometer, you have to remember these rules. First, be super gentle with it because it's made of glass. Always clean it before and after you use it. When you're ready to read the temperature, hold it right at your eye level to get the correct number. And here's a pro tip. Try not to touch the little bulb at the bottom while you're taking a measurement, because the heat from your fingers could mess up the reading.
And there you go. You are now officially a heat expert. You know how we feel heat, how we measure it, and how it moves all around us every single day. So here's my challenge for you. As you go about the rest of your day, where else can you spot the amazing science of heat at work? Keep your eyes open and keep exploring.